A computer network or data network is a telecommunications network which allows computers to exchange data. In computer networks, network computing devices exchange data with each other along network links. The connections between nodes are established using either cable media or wireless media. The best-known computer network is the Internet. Network computer devices that originate, route and terminate the data are called network nodes. Nodes can include hosts such as personal computers, phones, servers as well as networking hardware. Two such devices can be said to be networked together when one device is able to exchange information with the other device, whether or not they have a direct connection to each other. Computer networks differ in the transmission media used to carry their signals, the communications protocols to organize network traffic, the network's size, topology and organizational intent. In most cases, communications protocols are layered on other more specific or more general communications protocols, except for the physical layer that directly deals with the transmission media. Computer networks support an enormous number of applications such as access to the World Wide Web, video, digital audio. History. The chronology of significant computer network developments includes: in the late 1950s, early networks of computers included the military radar system semi-automatic ground environment. In 1959, Anatoly Ivanovich Kitov proposed to the Central Committee of the Communist Party of the Soviet Union a detailed plan for the reorganization of the control of the Soviet armed forces and of the Soviet economy on the basis of a network of computing centers. In 1960, the commercial airline reservation system semi-automatic business research environment went online with two connected mainframes. In 1962, JCR Licklider developed a working group he called the Intergalactic Computer Network, a precursor to the ARPANET, at the Advanced Research Projects Agency. In 1964, researchers at Dartmouth College developed the Dartmouth Time-Sharing System for distributed users of large computer systems. The same year, at Massachusetts Institute of Technology, a research group supported by General Electric and Bell Labs used the computer to route and manage telephone connections. Throughout the 1960s, Leonard Kleinrock, Paul Barron, and Donald Davies independently developed network systems that used packets to transfer information between computers over a network. In 1965, Thomas Merrill and Lawrence G. Roberts created the first wide area network. This was an immediate precursor to the ARPANET, of which Roberts became program manager. Also in 1965, Western Electric introduced the first widely used telephone switch that implemented true computer control. In 1969, the University of California at Los Angeles, the Stanford Research Institute, the University of California at Santa Barbara, and the University of Utah became connected as the beginning of the ARPANET network using 50 kbit per second circuits. In 1972, commercial services using X25 were deployed, and later used as an underlying infrastructure for expanding TCP/IP networks. In 1973, Robert Metcalfe wrote a formal memo at Xerox PARC describing Ethernet, a networking system that was based on the Aloha network, developed in the 1960s by Norman Abramson and colleagues at the University of Hawaii. In July 1976, Robert Metcalfe and David Boggs published their paper, Ethernet, Distributed Packet Switching for Local Computer Networks, and collaborated on several patents received in 1977 and 1978. In 1979, Robert Metcalfe pursued making Ethernet an open standard. In 1976, John Murphy of DataPoint Corporation created ARCNET, a token passing network first used to share storage devices. In 1995, the transmission speed capacity for Ethernet increased from 10 mbit per second to 100 mbit per second. By 1998, Ethernet supported transmission speeds of a gigabit. The ability of Ethernet to scale easily is a contributing factor to its continued use as of 2015. Update. Properties. Computer networking may be considered a branch of electrical engineering, telecommunications, computer science, information technology or computer engineering, since it relies upon the theoretical and practical application of the related disciplines. A computer network facilitates interpersonal communications, allowing users to communicate efficiently and easily via various means: email, instant messaging, chat rooms, telephone, video telephone calls, and video conferencing. Providing access to information on shared storage devices is an important feature of many networks. A network allows sharing of files, data, and other types of information, giving authorized users the ability to access information stored on other computers on the network. A network allows sharing of network and computing resources. Users may access and use resources provided by devices on the network, such as printing a document on a shared network printer. Distributed computing uses computing resources across a network to accomplish tasks. A computer network may be used by computer crackers to deploy computer viruses or computer worms on devices connected to the network, or to prevent these devices from accessing the network via a denial-of-service attack. Network packet. Computer communication links that do not support packets, such as traditional point-to-point telecommunication links, simply transmit data as a bit stream. However, most information in computer networks is carried in packets. A network packet is a formatted unit of data carried by a packet switch network. In packet networks, the data is formatted into packets that are sent through the network to their destination. Once the packets arrive, they are reassembled into their original message. With packets, the bandwidth of the transmission medium can be better shared among users than if the network were circuit switched. When one user is not sending packets, the link can be filled with packets from other users, and so the cost can be shared with relatively little interference, provided the link isn't overused. Packets consist of two kinds of data: control information and user data. The control information provides data the network needs to deliver the user data, for example, source and destination network addresses, error detection codes, and sequencing information. Typically, control information is found in packet headers and trailers, with payload data in between. Often the route a packet needs to take through a network is not immediately available. In that case, the packet is queued and waits until a link is free.